In section 1.5, we're going to start drawing pictures of sets as opposed to using the curly set braces to represent sets. And when we draw pictures of sets, we're going to do a lot of shading, and it will help quite a bit if you have something colored around that you can shade a picture with. And I like to shade with highlighters, and I went and got thick highlighters this morning because it'll make the shading go quicker. Usually I use these skinny highlighters, but it takes a lot longer to do the shading with skinny highlighters than it does big old fat highlighters. So I went and got some this morning. So a Venn diagram is actually a picture or a way to graphically represent sets and set operations like complement, intersection, and union. And in our class, when we try to draw a picture that represents a group of sets, which is a Venn diagram, it's just a picture that represents some group of sets, we usually start by drawing a rectangle representing the universal set. So a typical Venn diagram that is a pictorial representation of some sets usually starts out with a big old rectangle, and somewheres in this big old rectangle I write the letter U, and that U represents the universal set. So everything for a particular group of problems when we're trying to represent sets with pictures is going to take place inside of a big old rectangle, and the rectangle is the universal set. In our class, we're going to be studying Venn diagrams that have either 2 or 3 subsets. In the last section, we had some problems where we created a universal set, and then we had maybe 2 subsets of the universal set, or we had some problems where we had a universal set and we had 3 subsets of that universal set. And then we're going to restrict ourselves to those kinds of problems in section 1.5. It's certainly possible to have a universal set with 100 different subsets, but then to pictorially represent the situation where you have a universal set in more than 3 subsets gets kind of cumbersome to look at, so we won't worry about more complicated representations of a universal set with a couple of subsets. Generally, when we're given a situation where we have a universal set and either 2 or 3 subsets, the subsets that are going to be represented with overlapping circles. And let me show you how to graphically show this situation right here, where we have a universal set with 2 subsets. Usually, when we have a universal set with 2 subsets and we want to pictorially represent those sets with a Venn diagram, we generally make the universal set a big old rectangle, and then we draw a circle for each of the subsets of the universal set, and we usually make those circles overlap. And I generally write the names of the circles of the sets somewhere either in the circle or right next to the circle, depending on I don't know what I'm feeling inspired by at the moment. So this would be a pictorial representation of a universal set with the subsets A and B. A little bit later in the video I'll do this pictorial representation, but not at first. These are a little bit easier to deal with, so I kind of want to beat these to death first, and then move on to the more complicated scenario where we have one universal set with 3 subsets. On the next page, I typed some stuff up that's exactly this. So here's a Venn diagram for the 2 sets A and B and the universal set U. So you'll notice that I made my big rectangle. Somewhere in my big rectangle I wrote the letter U, or typed the letter U, and I made overlapping circles, one I called A and one I called B. Here I wrote the A right next to but not inside the circle that represents A, and I wrote the B right next to but not inside the circle that represents B. doesn't really matter. As long as I can tell that the left circle and the right circle, what sets they stand for, you don't have to have the letters inside the circle. They can be right next to the circle. So let's talk about how we're going to represent sets visually. So to represent sets or intersections, complements, unions of sets with a Venn diagram, we usually shade the Venn diagram to illustrate the set that we're talking about. And this is the most simple Venn diagram. This Venn diagram is associated with the set A. This is a picture. If I said represent the set A in the Venn diagram that I gave you here, we would just simply shade the inside of that set. So to represent set A, I take my Venn diagram for the two sets, and the best I can, I'd shade and kind of stay inside the lines. That would be a picture, a Venn diagram representation of the set A in the universe where there's a universal set and two subsets of that universal set A and B. The next few pages are no longer going to be typed. I spent, an insane amount of time typing up my explanations for this section, and it takes a long time to get through the work when I have it all typed up, and I don't think it's going to be as productive me going through my typing to help you understand than just to kind of free-form lecture. And so before we get to the problems, we have to understand how to represent different sets using Venn diagrams, and I'm going to do that without using my typing, and this will be supplant what I have typed up. So if I actually stuck with my typing, the next page would explain how to create a Venn diagram to represent the set A complement. And that's easy to do in this world of two sets. So my generic Venn diagram is going to have a universal set and either two or three overlapping sets. At the beginning of this section, we're going to only deal with two overlapping sets. If I'm asked to make a pictorial representation of A complement, remember by definition, A complement is everything in the universal set that's outside the A set. Pictorially, I represent that by shading. I'll try to shade a little bit better here in a second. But pictorially, A complement is everything that's inside the universal set that's not part of the A set. This is a lightly shaded version of what A complement is. Let me just darken this up. My niece was here. She likes to color and shade so much more than I do. She does it better. So this is going to be a pictorial representation that shades only the region of the graph that is associated with A complement. The smaller that you make these Venn diagrams, the easier your shading is. So pictorially, A complement is, or by definition, A complement is all the elements in the universal set that aren't part of set A. This is how that's represented pictorially. Set A is left blank, and everything outside set A is shaded. So this is shading everything inside the universe that isn't part of set A, and pictorially that's what A complement looks like. To draw a Venn diagram for the sets A union B, it's super easy to do. A union B consists of any element that's either in set A or set B or in both sets A and B. I try to make my picture a little bit smaller here so I don't have to shade quite so much. So this is my universal set. I'm going to write the A and the B outside the set so they don't get destroyed by my shading. So to do the set that represents A union B, I simply first shade the set that represents set A. And there's a picture of set A being shaded, so I've got that done. And also I'm going to shade set B, and set B is the entire B circle. Notice that I'm shading some area twice, but that's okay. This is a picture of A union B. There's no, this picture contains every element in set A, every element in set B, and every element that's in both set A's and set B's. When we're doing unions without Venn diagrams, we have to make sure we haven't written some element twice, and we have to only rewrite it once. When we're shading, finding the union of Venn diagrams, I don't have to worry about throwing out anything. I did wind up shading this center region twice. Not such a big deal because it needed to be shaded, and there's no overlapping. There's nothing to throw out like when you're doing it by hand. So the first two shadings that I've done a shading of a complement, a shading of a union. In some sense, with shadings, unions and complements are easier than intersections. When we're doing operations by hand, intersections are a little bit easier. Intersections, I generally use two colors to draw an intersection. And I often do an initial picture and then an answer picture. Let me pick some highlighters that might be lighter. So when I do a Venn diagram for a intersection, I usually use two colors to represent each set with a different color, because an intersection is trying to find out what the sets have in common, and pictorially to find out what the sets have in common, here's a picture of set A. Now I'm going to do a picture of set B. It's not working so well. That color didn't really blend the way I hoped it to blend. The intersection of these two sets, I might have to pull out my old-fashioned markers. The intersection of those two sets, let me try to redo this because I just don't like the way that showed up. So let me try to do A intersection B again with my old school markers. Do I have them even? Not so much. Well, let me try to wing it and see what I can get done with here. So, an intersection we usually do with two colors, and the picture that we draw usually is too complicated for a final answer. So if I want to show A intersection B, I can start off by showing the A circle, and the A circle, the set A is that. I just did it in blue this time. To it, I'm going to try to add the set B, which I'm going to try to do in orange again. And the intersection of A and B is where the different color shadings overlap. It's where my blue and my orange shading overlap. So this is kind of a temporary Venn diagram to help me get my answer, but it's not the answer. This doesn't only have A intersection B highlighted. So Venn diagrams that ask you to show intersections are a little bit more complicated than Venn diagrams that ask you to show unions and those that ask you to show complements, because the intersection of A and B is that region right there. It's the region where the shadings overlap. So Venn diagrams will get progressively more complicated, and it turns out that intersections are more complicated to represent with Venn diagrams than unions are complements. So there's three big Venn diagrams that we need, generic ones that we need to be able to show. We need to be able to show a complement of a set, which is the entire region of the Venn diagram, not including that set. We need to show a union of two sets, and that's just shading in each of the sets that were named with one color. and we need to be able to show an intersection of two sets. And to show an intersection of two sets, I generally draw each of the sets in a different color, and that gives me a temporary drawing. And then I look at those pictures that I drew, and I look for the shadings overlap. The intersection isn't everything that I have shaded, it's just where the shadings overlap. Those are the three big shadings that I need to be able to do. And then of course, we're going to have to be able to do some of those shadings in more complicated problems. So let me try to show this picture, which is A complement intersection B. Because it's an intersection, I'm probably going to have to draw multiple Venn diagrams to get my answer. And I'm going to draw those Venn diagrams using different colors because of the intersection. So here's my universal set. Here's my set A. Here's my set B. The region I put A inside the circle and B outside the circle is, I don't know, I just thought it was going to be smart because when I go to draw A complement, I need to draw everything outside the A circle. And then when I go to draw B, it's everything inside the B circle. So in order to do an intersection of two sets, you have to make pictorial representations of the two sets. I'm going to do A complement in green. And maybe I'm not going to shade perfectly. And this isn't my final answer anyway, so it doesn't need it to be shaded maybe quite as nice as if something I was going to call final answer. So A complement is designated by that shading right there. It's everything that's not inside the A circle. Since I'm doing an intersection, I'm going to pull out a second color. And in my second color, I'm going to shade B. And B is just everything inside the B circle. So those are the individual shadings I needed to do in this problem. I needed to do a shading for A complement, and I needed to do a shading for B. My answer, because this is an intersection, is any region where both shadings exist at the same time, or where the colors overlap. So when I go to write an answer for what region represents the sets A complement intersection B, I look at my shadings, and I see where the shadings overlap, and I transfer those to my answer. And it looks to me like this region right here is the only region on the graph where I have both shadings. Either outside the circles I only have the green shading, in that region there I have no shading, in that region I have pink shading, and in this is the part of the graph where I have both shadings. More complicated when we have a parentheses. To make a picture of A union B complement with a parentheses, I have to first make a picture of A union B, and I reminded myself that I already made a drawing for A union B, and I said, heck, it's going to help if I use that drawing. So when I need to draw A union B complement, I have to do the inside of the parentheses first. The inside of the parentheses asks me to draw a picture of A union B, and to do the picture of A union B, I made a circle with A and a circle with B, all highlighted in the same color. So real quickly, I'm going to draw that picture of A union B, and it's going to help me get my answer for what A union B complement is. So I have my universe, my set A, and my set B, and this is a representation of A union B. It's not what I'm asked to draw for my final answer, but it's going to help me get my final answer. My final answer asks me to take the complement of this set. And the complement of any set would be the part of the Venn diagram that isn't shaded when you draw that set. My answer to what the graph of A union B complement is going to be to find the complement of the graph of A union B. And the complement of any graph is the rest of the universe. It's any part of the universe that isn't shaded in the graph of that set. So this is the set A union B. The graph of A union B complement would be everything that's inside the universe that's not shaded when you shade that set. So A union B is the inside of the circles A and B, A union B complement is going to be the outside of those circles. And I shouldn't be shading anything inside the circles to represent A union B complement, although some of my shadings went over the line. We'll have to understand that I draw worse than a 3-year-old. And this is the complement of that, which means basically I whitened those and darkened everything outside the circles. All right, so now we're ready to do a few homework problems. Yick. And they're both intersections. Let me try to work through my problem 2. It's an intersection, so I'm going to have to draw each set that's represented in a different color. So for all the problems between 1 and 9, I'm going to have my universal set, my set A, and my set B. If I'm doing intersections, I need to use 2 colors. If I'm doing unions, I need to use 1 color. Intersections, I'll have to do multiple graphs to represent my answer. The first thing I'm going to do in green for problem 2 is represent A complement. And A complement is every bit of this graph that's outside the A circle. So I go right up to the A circle. I wish I had some artistic ability, but I don't. So that's a picture of A complement. It's the only thing that isn't shaded is the A circle. Now, on the same graph, in a different color because I'm doing intersection, I want to show B complement. B complement is everything that's outside the B circle. So I'm making a little ring around the B circle, and I'm shading everything that's outside of that ring. My answer to problem 2, because it's an intersection, is any of the regions that have both colored shadings. And sometimes it gets hard to tell where you have both colored shadings, but I don't think so much in this one. So I have my universal set, my set A, and my set B. This is going to be a graph of A complement, intersection B complement. And as I look at my shadings, it looks to me like anything inside the A circle or inside the B circle either only has 1 shading or it has no shading, so it doesn't need to be part of my answer. But everything outside the A and the B circle, all this region out here, has multiple shadings. You'll notice that this is the same graph as A union B complement. There's something called the Moores Theorem that tells me that the graph that I did for parentheses A union B complement is the same as A complement intersection B complement. That's not something that we need to worry about in our class. The Moores Theorem is not something we're asked to teach. So that would be my answer to number 2. That's a picture of the region A union A complement intersection B complement. So hopefully you can do something similar for number 1. Just in case it isn't going so well yet, why don't you pause the video and give number 3 a try, and then I will do it for you. And if you're not ready to do number 3 yet, I'll do it, and you can watch me. And hopefully the more examples you see, the better you'll get at this. So to make a picture of A complement union B, I only need 1 color, and I won't have to do multiple pictures, because unions can be represented with 1 color. So I'm going to represent the set A complement with 1 color, and I'm going to use the same color to do set B. So A complement is everything that's outside the A circle. So there's a picture of A complement. If I was doing an intersection, I would draw B in a different color, and then I'd draw a second Venn diagram to show where the shadings overlap. But because it's not, and it's a union problem, I'm going to continue shading the next set using the same color, and this is going to be my answer. So to union B, technically now I need to shade in the entire B circle. Any of the regions that's shaded is my answer. So my answer to problem 3 would just be this picture right here. This is a representation of A union B. If you want to see a nicer picture, you can look at my answers, and this is exactly the answer that I wrote for problem 3. Here's the answer you should have got for problem 1. You'll see that on my answers, I'm able to do this on my computer, so it's kind of easy to do the well, it's a pain, it's a major pain to draw this on my computer, but nevertheless it's easier to read. So these are the regions that should be darkened, and that little moon, quarter moon region should be highlight empty. And that's what I tried to represent there. I don't know how good my representation is, but it is what it is. So when I'm doing unions, I only need to pull out one color. When I have parentheses, I probably am going to have to accomplish this with 2 Venn diagrams, and maybe even 3. So first in problem, so I'm going to do problem 6. The first thing I'm going to try to do is do the inside of the parentheses, because that's kind of my order of operations. And because the inside of the parentheses has an intersection, it's going to take me 2 Venn diagrams to represent what's inside the parentheses. So the first thing I'm going to show using 2 colors is the A intersection B complement. And again, the smaller that you draw, the less shading you have to do. So let me do this with 2 colors. First, I'm going to do A in this orange color, just because it's one I happen to pick up. And then I'm going to do B complement in this blue color. And B complement is the whole Venn diagram. If I make a ring around the B circle and I shade outside of that B circle, I've shaded what B complement is. So that's too cumbersome, too ugly of a representation of this. I need to clean this up a little bit, and the picture for A intersection B complement would be where the 2 shadings overlap. And to me, I can tell the region where I have both the orange and the blue shading, and hopefully you're good visually, and hopefully my cruddy drawings aren't slowing you down in your understanding of this. So the region that represents A intersection B complement is going to be the region where I have both the orangish and blue shading, and that looks to be like this region right here. It's not my answer, because my answer needs to take the complement of this. So I'm about ready to write my answer, and I think I'm going to do it on just one final graph. So I'm trying to draw A intersection B complement, the complement of that. Not so hard to do, because I know what the inside of the parentheses look like. I just need to take the complement of the set that I have drawn there, and the complement of any set is the rest of the universe. So to complement this set, I just want to make and draw anything that's not part of this set. And then my answer is going to have everything that's not part of this region. So I'm going to go around the region that I just drew and shade everything that's outside that region. And so the only thing that's going to be open in my answer is the only thing that's shaded in the region above it. So I took the complement of that graph. The complement of any graph is essentially shading in the rest of the universal set. That's going to be my answer to number 6. You want to give your problem 5 a try, and your problem 5 is going to have, well, I'll flash up the answer just in case you need to see it. Your problem 5 is going to have an answer like that for your final answer. And you might need to do it in 2 or 3 graphs like I did. Okay, there's a 7, 8, and 9 left. And what's harder? Let me do one of your homework problems. Let me do 7 for you, just in case these things aren't going so well yet. So to do 7, the first thing I'm going to do is I'm going to do A complement union B. Because it's a union, I can do it with one graph and one color. Intersections, I probably need 2 graphs and 2 colors. So I make my universal set, my set for set A, my set for set B. It doesn't matter if I write the A and the B inside or outside the sets. It's just a matter of kind of preference. So let me, with one color, show A complement union B. First, I'm going to show A complement, and A complement is anything that's not inside the A circle. So I just drew a bar around or a band around the A circle, and now I'm showing A complement, which is every bit of the graph other than the A circle itself. So I've done the A complement. If it was an intersection, I'd pull out another color, but this is a union, so I don't need to pull out another color. I'm going to do set B in the same pink. So set B asks me to shade everything inside the B circle. So I just shaded everything in the entire B circle. That's a picture of what the inside of the parentheses looks like. It's not going to be my answer because my answer asks me to find the complement of the inside of the parentheses. So my answer is going to be whatever the complement of the set that I just drew is. And of course, to do a complement of a set, you shade anything that's not shaded. My answer is going to be the complement of this drawing. And again, the region that's whited in, I'm going to shade it. The regions that's shaded, I'm going to leave white. So that's going to be the answer to problem 7. And again, if you want a better picture, you can certainly look at my answer key. It has nicer pictures than I can do by hand. So you have problem 9 to do, and then we're going to move on to Venn diagrams that have 3 subsets. It's easier to work with 2 subsets, the subsets A and B, than it is 3 subsets A, B, and C. When we do a Venn diagram that has a universal set and 3 subsets, we're going to need to represent the 3 subsets with overlapping circles, and these are a little bit harder to do. So the Venn diagram for this representation, where we have a universal set, a subset A, a subset B, and a subset C, is going to have 3 overlapping sets, and I always draw each of these sets with a circle. I usually make the A in the upper left, the B in the upper right, and the C in the bottom, and I try to make the regions overlap. And in this Venn diagram, if I ask you to represent set A, you would just shade in set A. So this is a picture of Venn diagram, a 3 subset Venn diagram that represents the set A, as opposed to, the one that would represent set A when we have 2. All the rules are going to be exactly the same. There isn't anything necessarily new when we go from 2 sets to 3 sets, but the problems can get quite a bit more complicated. And in some of our examples, I had to do 2 or 3 Venn diagrams to get to an answer. I can foresee it taking 4 Venn diagrams to get to an answer of a union complement intersection kind of problem when we have 3 sets. So let me draw a 3-set Venn diagram to represent A complement. So I draw my universal set with a rectangle. In the upper left-hand corner, I write a set A. Right next to it, I write my set B. And underneath them, I write my set C. And again, as long as the name of the set is close to the circle, it doesn't have to be inside the circle. So to draw A complement, I'm going to draw a ring around the set A, because I don't want to shade inside that. And I'm going to shade everything outside that ring, but inside the rectangle. So this is, maybe not the most professional drawing, but this is supposed to be a picture of A complement. It has everything inside the rectangle shaded other than the regions inside the A circle. All right, so let's see how we do 3-set Venn diagrams with unions. Unions are easier because I only need one color to do unions. So let me draw a 3-set Venn diagram for A union B union C. I draw my 3 circles, label one of them A, another one B, and another one C. And I'm very consistent. I always label them the same way. If you picked up another text, teachers will, make the picture look different, but there isn't any reason it needs to look different. So let me do A union B union C. Because there's only unions, I can do this all with one color and one graph. To do the A part of this, I shade everything inside the A circle. So that's the A part of A union B union C. Now I'm going to do the B part. Because it's union, I can stick with one color. So now I'm shading everything inside the B circle. I'm covering up some shading that I already did, but that's okay. And then I'm going to do the C part and shade everything inside the C circle. All in one color because it's only union. That's a picture of A union B union C using a 3-set Venn diagram. So unions are just so nice because I can usually represent a problem that only has unions with one color and only one Venn diagram to get my answer. Once we start mixing intersections into the mix, especially when we have 3 sets, it'll get to be so that I'm probably going to have like 3 or 4 Venn diagrams to get to my answer. So let me try to show you how to represent A intersection B union C. So I'm drawing my 3-circle Venn diagram. I tried to make it a little bit smaller because I knew I have a lot of shading to do. So let me try to show first A intersection B, because I have to work from left to right. And the left to right, the first thing is an intersection. And intersections aren't my friends because I have to do them with 2 colors or be able to visualize the intersection and skip this step. So this is not a picture of A intersection B. The picture that I need for A intersection B would be where the shading that I just did, where the shadings overlap. So I have my universal set, my set A, my set B, my set C, and what I've drawn so far is A intersection B, and A intersection B is just that region right there. Quite honestly, I know what A intersection B looks like, and I don't need to draw 2 Venn diagrams to figure out what A intersection B is. So I'm done with part of this problem. I've figured out what the A intersection B is, have that in one color, it's pink, and now I want to union that with C. Very easy to do a union now, because to do a union I don't need to pick out a new color and I won't need to do another graph. To union with C, to union the graph of A intersection B with the graph of C, I simply, to the graph of A intersection B, color in the circle for C. And that would be it. This is the answer to the Venn diagram that represents the region A intersection B first and then union C. So I worked from left to right. I found A intersection B. I represented it in the color pink, and then I unioned that with the color with C. And because I'm unioning this set with that set, I could all keep it all in one color. I needed to do 2 colors to get the intersection taken care of, but once I got the intersection taken care of and had this represented as a single region, then I can union with this one more color. Let's try another horrible problem. So now I'm going to first represent A complement intersection B, and it's going to take me 2 steps to do that, but you might be able to do it in 1 step. So I'm going to draw my universal set with the 3 subsets. First I'm going to do A complement, and I might as well do it in pink because I have pink in my hand. A complement is everything outside the A circle. Since I'm intersecting, I need to do these in a different color. So I did my A complement, I did it in pink. I'm going to do my B in green. And then A complement intersection B is going to be any region that has both the pink and the green shading. And hopefully that shows up okay. So I have my universal set, my set for A, my set for B, my set for C. And I try to visualize where the shadings overlap. So I needed both pink and green shading, and let me just do this in lovely blue. So this right here seems to be the region above that is the intersection of the pink and the green shading. So this is a representation of A complement intersection B. For my answer, I need to find A complement intersection B, which I have pictured there, and I need to union that with C. Because I'm doing a union, I won't need to create a new graph. I should be able to add that union to the graph that I created for the first thing I needed to find, A complement intersection B. And to union this with C, I'm just going to go shade in the entire C region, and that would be the perfect answer for A complement intersection B union C. So I worked from left to right. I got in a pictorial representation of A complement intersection B, which was kind of those two regions, and then I added to it in the same color, because I'm unioning and I can do that with one color, everything in the C. All right. One more example before we start getting into the homework problems. So I need to do parentheses first, and it's an intersection after the parentheses. This is going to be a monster problem. So let me first, with a small Venn diagram so I don't have to shade so much, try to represent the inside of the parentheses first, which is A union B. A union B, because it's a union, I can do in one color. A union B, I take the entire A circle, shade it in, and I shade in the entire B circle. So I shaded the entire A circle and the entire B circle one color because it's union. That's not a picture of my parentheses. My parentheses asks me to draw A union B complement. And the complement of any set, of course, is anything that's in the universe that isn't shaded when I shade those sets. So the complement of A union B, let me just do it in some different color, is everything outside what I shaded for A union B. So it's everything that's outside. Notice I didn't write letters down for A, B, and C. That's okay, because I always put my A, B, and C in the same spot. If I forgot to write the letters, I still know that this set is A, this set is B, and that set is C. So that's A union B complement. Now I'm going to have to, unfortunately, intersect that with set C. So now I'm going to intersect the set that I have drawn, A union B complement, with the set C, which is a set down here in the bottom left-hand corner. The A is there and the B is there. So how do I intersect? I pull out a different color, and I draw the set that I'm intersecting with in a different color. So A union B complement, that region is represented in green. I'm going to represent in pink the region for C. And my answer to what A union B complement intersection C would be any region that has both the green and the pink shading. So my answer to this problem, what does the region A union B complement intersection C look like? Well, I have to interpret that drawing that I have, and it gets, sometimes it gets messy to really figure out where both shadings are. But to me, it looks like just in this little piece right there, in the little part of the C circle that's underneath the pink shading is where my answer is going to be. Let me try to illustrate what I believe is the only region that has both the green and the pink shading, because the green shading is outside the A and the B circle, and the pink shading is inside the C circle. So I need to have the region that's inside the C circle but outside the A and the B circle, and that would be that region just right there. All right, homework problems. So let's try to work through this. Let me do number 11 with you, just so that you can, just in case you're not ready to do this. Let me not do 10, let me do 11. If you want to, pause the video and see if you can get the answer without me. In problem 11, I need to work from left to right. The first thing I'm going to do is draw A intersection B. When we're doing Venn diagrams, I can kind of wait on doing the complements. When I'm doing things by hand, when I have, the physical sets, the complements need to be done kind of first. But I'm going to draw a picture. And intersections take me 2 steps to do, but you might be able to do it in 1 step. So let me draw A intersection B. And I'm going to draw, this time, my A in orange. I don't know why I'm not being consistent with my colors, but it doesn't matter. Whatever color you pluck up is fine. So I have my A drawn in orange. I'm going to do my B in pink. And to do my B, I'd shade the entire B circle. And then I try to figure out where do I have both shadings. And it's not that clear. But hopefully, when you're doing your drawings, you'll be able to look at your drawings well enough and know where you have both color shadings. And for me, I have shaded the whole inside of the A circle in orange, the whole inside of the B circle in pink, and where those 2 shadings overlap is going to be that region right there. This is where I have the orange shading and the pink shading overlapping. That's the region A intersection B. So now I have my A intersection B drawn in blue, and I need to union that set with C complement. The nice thing is when I do a union, I don't need to pull out another color. So right on this graph, I'm going to draw C complement in the same blue. To draw C complement, I make a little band around my C circle, and I shade everything that isn't inside that C circle. Some of it I've already shaded, but not all of it. So anything that's shaded right now is going to be part of my answer to number 11. I claim that this is my answer to number 11, and that answer is supposed to be the same as this answer. I don't know how much my answer looks like that answer, but my goal was to leave kind of those 3 little segments of the graph unshaded, and I shaded the graph that I intended to shade, which is those regions. So as you're going through and doing your shadings, I mean, I have to cut you a little slack because I don't have the best shadings ever for some of my problems. All right, so I'm going to do 12, and you can do 13. I don't want to do all your problems. Lots of intersections here, so I need multiple colors. So as I do number 12, I'm going to work from left to right. I'm going to start off doing A intersection B complement. And again, I can do this in 1 shading if I'm not trying to explain how to do it. If you can do this in 1 shading as well, that's better than having to take the 2 shadings to do the intersections. So A intersection B complement, let me do my A in orange. That's everything inside the A circle. And I'm going to do my B complement in pink. That's everything. If I make a band around the B circle, that's everything outside the B circle. So that's technically the entire A circle drawn in pink, the entire the outside of the B circle, the entire A circle drawn in orange, outside of the B circle drawn in pink, and this region, I need to refine that into a second graph that shows just the part that I need to show. So the region where both the shadings overlap is not so clear. So I need to be outside the B circle and inside the A circle. That's what this means. It means inside the A circle and outside the B circle. The region of the graph that's outside the B circle and inside the A circle is going to be this region right here. This region that's outside the B circle, it's inside the A circle. In this region, outside the B circle, inside the A circle. The rest of the regions are either not inside the A circle or not outside the B circle. So the two shadings that I did, they overlapped in that region. Now, to this graph right here, I'm going to add the last part. The last thing I need to do is intersect that graph with C. And how do I intersect a graph? I bring out a new color to represent the set. So I just drew C in orange. My answer is going to be where I have both color shadings. So intersections, it usually takes me a couple of graphs to represent. My answer to the region that needs to be shaded to represent A intersection B complement intersection C is going to be the regions in this graph where I have both the blue and the orange shading. So that's just blue. That looks like blue and orange. And this little circle right there, that's unshaded, unshaded, unshaded. Just orange, blue and orange, just blue, no shading. So the region that I'm going to need to show is just this region right here. This is the only region that has both blue and orange shading. Because just blue, just orange, no shading, no shading, no shading, no shading. My answer for problem 12 should look just like that. Your answer for 13 should look something like that, just in case you gave 13 a go and you wanted to check. Let me try to get 15 with you. Let me try to get this answer for 15, and I won't do 14. So again, if you're not feeling good about these, pause the video, try to get 15 accomplished, and if you got it, fast forward through this and don't watch me do it. So the beautiful thing about problem 15 is that there's no intersections. And when there's no intersections, you don't have to worry about multiple colors. So on one graph simultaneously, I'm going to draw each in one color. I'll use blue. First, I'm going to draw A complement. To do A complement, it's the entire region outside the A circle. Let me try to draw this in by my standards nice. So A complement is everything, absolutely everything that's outside the A circle. So I've got that done. And now I'm going to union that with B's. In unions, I don't need to pull out a new color. To unioning it with B, I'm going to shade everything inside the B circle. Some of it was already shaded. I just darkened it up, but it didn't matter whether I did or didn't darken it. And then lastly, I'm going to, because it's another union, keep my blue color and do the C. And now I'm shading everything inside the C circle. Anything that's been shaded, regardless if it's been shaded once, twice, or 3 times, is going to be part of my answer to problem 15. The only region that's empty is this little part of set A, and that's exactly the answer that I have drawn on your answer key. Alright, so I'm going to do 16 and let you do 17. I'll flash up the answer to 17 so you can check your answer. And again, if you don't need to watch me do 16, fast forward through it. It doesn't hurt my feelings at all. The first thing I'm going to do when I do problem 16 is do to B intersection C. And quite honestly, I can do that in one graph, and I'm going to start being lazy. Should I? Yeah, I think I'm going to start being lazy because it shouldn't be that hard to figure out an intersection of 2 sets. So B intersection C is the region where the B and the C circles overlap. I could draw the whole B circle in one color, the whole C circle in one color, and figure out where the shadings overlap. Those shadings are going to overlap right there because those are the regions where the B and the C circle overlap. That's what B intersection C is. Unfortunately, I don't need B intersection C I need the complement of B intersection C. So now I'm going to draw the complement of B intersection C, and that is going to cover up almost everything, because the only thing that's going to be left white is the area that's blue. So B intersection C complement is everything outside that, everything that I haven't shaded above is going to become shaded to do B intersection C complement. I got my new markers, but I don't like them. They're harder to draw with than the markers that I've used forever. So that's a picture of B intersection C complement. All I need to do now is union that with set A to get my answer. And because it's a union, I should be able to get my answer all in one graph and all with one color. So I'm going to union this graph with set A. And to union it with set A, I circle and I draw in everything in set A. The only region that's empty is this little region right inside the overlapping part of the B and the C circle. So I don't know if that's the best drawing in the entire world. Hopefully you can figure out from my work from my drawing what the answer is. Just has a little region right there open. And again, just in case, your answer to 17 looks like that. Let me walk through 19 with you and see if we can get this really odd looking region for our shading. It's actually going to be an easy problem. So in 19, I won't do 18, I'll do number 19 for you. In 19, because there's a parentheses, I have to do it first. So the inside of the parentheses in number 19 wants me to do B intersection C. And again, that's just where the B and the C circles overlap. I can do that using multiple shadings, but hopefully I've done enough intersections that you can start to realize what intersections look like. So B intersection C is where the C circle and the B circle overlap. That's those two regions right there. That's that's where the B circle and the C circle have in common. Now I need to finish this up, so I did the parentheses first. To finish this up, I'm going to union A with this. I don't need to pull out another color to do union A. I just need to now, with my same color, draw in the entire A circle, and that's going to be my answer, because that's how you union sets, by just adding the new set in the same color. When I look at my answer to problem 19 compared to the answer that I've just written, they're supposed to be the same. So you should, again, be able to tell the regions that I have highlighted, the best you can. So just a few more problems. Our problems for problems 20 and 21 are so similar. I'm going to do problem 20. I'm going to start off by doing the parentheses. The parentheses is a union, so I can do it in one color. I need to do A union C. I'm going to represent that in one color. So I have my universal set, my set A, my set B, my set C, and A union C in one color. I'm going to shade the entire A circle, and in that same color, because it's a union, I'm going to do the entire C circle. So that's a representation of the A union C. To this, I have to intersect B. So now I have to do B intersection, that set A union C. A union C I have represented in blue. Because I'm doing an intersection, I need to pull out a separate color. So I'm going to do, on the graph of A union C, I'm going to graph B, which is anything inside the B circle. The answer is going to be any region where I have both colored shadings. And my answer to problem 20, I need to interpret the graph that I have just drawn, and any of the regions that have both the blue and the pink shading simultaneously, I'm going to bring out and write in my answer. So it looks to me like this region up here has both colored shadings, the region under it has both colored shadings, and the region to the right of it has both colored shadings. Any other of the regions either have no shading, or they're shaded just in pink or just in blue. So this is what I would call the answer to problem 20. Your 21 should work remarkably similarly. We're left with just one problem to do. And let me do your 23 again. So you can pause the video, try to do 23, and if you can't get it, watch me do it. If you can't, you're shooting for that answer. So if you do 23 and get that answer, you don't need to watch me do it. You're done watching the video. If you can't do 23, let me help you through it. So for 23, I have to do the inside of the parentheses first, which is B union C. I can easily do that with one color, because unions I do in one color. So I draw my union, my A circle, my B circle, my C. B union C, one color I draw in the entire B circle and the entire C circle. That's B union C. I have both the B and the C circle represented perfectly. Now I'm going to complement that, and of course to complement a set you shade what's not shaded. So I'm going to take the set that I've just drawn and form its complement. I form its complement by shading what's not shaded. So what's not shaded, or what's in white in the picture that I have just drawn previously, is now going to become shaded. So this is a reasonable picture. That I would call B union C complement that. I'm not done, because in problem 23 I have to intersect that with A. So now I need to do A intersection B union C complement. To do an intersection, I pull out a new color. So my B union C complement is represented in blue. I'm going to represent my A in pink. And to represent A, you shade the entire A inside of the A circle. And of course, intersections, I need multiple graphs. The next graph is going to be my answer. And my next graph is only going to have the region in the above graph where I have both the pink and the blue shading. And that looks like just this region right there. That small part of the A circle is the only region where I have two colors. So if you're careful with these and just kind of do the right orders of operations, it's not horrible to do. There's just the three operations, and now it's just drawing pictures to represent the three operations. And again, if I look at my answer to problem 23 and I look at this, they're intended to be the same picture. All right, so the next section is doing more Venn diagrams, so you need to be real comfortable with the Venn diagrams before you move on to the next section.